let's apply what you've learned about calculus to some economic problems. Here is a very, very simple macroeconomy. If you take an Econ 1010, this should look familiar to you. We've got output, which in Econ 1010 we call real GDP. You can think of that as real GDP if you wish. We have consumption and we have investment. And our first equation here says that real GDP supply is equal to demand. We've got a very truncated demand side to this expression is consumption plus investment. And we've got a bar over the I to represent that this is exogenous or a constant. Those are just two different ways you can think about it. You can say, oh, it's exogenous to the function. Maybe you haven't gotten there yet in your economic training. In our course, we would just say, oh, I is a constant number. Constant value. The next equation tells us what consumption is. I'll talk a little bit more about that later. Now, the first question asks us to combine these equations and find how output is changing when investment changes. So we're going to find the derivative. So let's get started. We've got y is equal to c plus I bar. I'm going to replace c with f of y. So we get f of y plus I bar. Now notice that y, the value of y output depends on I bar. And so y is an implicit function of I bar. And so we're going to get, I'll use prime notation, we're going to have y prime is equal to f prime y. What's the derivative of the inside? Y prime plus 1. Oops, not plus I. Plus 1. Change in I bar with respect to I bar is equal to 1. Now I'll collect like terms. And we've got 1 minus f prime y. Now let's look at question B. Question B asks us to give an economic interpretation to what we did in part A and what we were given in the question. So looking here, it should be fairly obvious that f of y is equal to a consumption function. Ooh, that looks like maybe it's too big. Let me try that again. If you have a value for y, the function will generate a corresponding C consumption value C. Right? So you plug in the y, some number for y, and it gives you the consumption. F prime y is the change in consumption when, well, we'll call it output, and if you're in Econ 1010, real GDP changes. And from Econ 1000, if this real GDP is real income, which it is, then f prime y is the marginal propensity to consume. So it's the marginal propensity to consume, MPC. Now question C says if f prime y, that's the marginal propensity to consume, is equal to 0.75, how will output change if we change investment? And the answer to that is to take what we came up with in part A. So from part A, we had dy di bar, which we just had as y prime, is equal to 1 minus f prime y. So there's our marginal propensity to consume. And so y prime is going to be equal to 1 over 1 minus 0.75, and that's equal to 4. So, based on our work, if MPC is 0.5, that means if you're consuming 75% of output, or 75% of output is consumed, the marginal propensity to consume is 0.75, then a 1 unit increase in investment will increase GDP, or I guess output, real GDP, by 4 units. Here's a question based on Econ 1000. We're going to look at supply and demand. So economists do a lot of work on supply and demand. Here we have a linear model. So you can see that when we're looking at demand, this B is the slope, and when we're looking at supply, beta is the slope. And like most linear functions, there is a non-zero, in this case positive, constant. Now the next part of the question, it's actually done part of it for us. It's combined these two equations. So we know that in equilibrium, demand is equal to supply. And that's what we have down here. We have demand is equal to supply. And we could solve for price, we could solve for P, and then we would know what the price is in equilibrium. Go back and solve our system of equations that we've got here, 2 equations, and that would give us the answer. And we're going to do something like that, but there's a little bit of a trick. We've got a tax. This tau represents a tax. And there's going to be a tax associated with the price, added on top of the price. Now we want to remember that price is going to be a function of the tax. So if we change the tax, we're going to change the equilibrium price. Now let's answer question A. Price is an implicit function of the tax, tau. So let's see how this equation here changes. All right, I'm going to take the derivative of both sides with respect to tau, and we get 0 minus b times the change in p over the change in tau, plus, or I should say, maybe we'll just expand it. I'll say minus b, the change in tau with respect to tau is just 1. And this whole thing is equal to 0. The alpha, the constant, disappears. And we're left with plus beta change in p with respect to tau. Now we want to collect our like terms. And so we're going to maybe move this one over here. So we've got plus b, change in p, change in tau, plus beta, change in p, change in tau, and this is equal to negative little b. And I'll factor out change in p over the change in tau. So now we've got b plus beta, just like that. And then now I divide both sides of the expression by b plus beta. So we're going to end up with d over p tau is equal to negative b over b plus beta.